Okay, it's time for example 2. A car traveling 20 meters per second sees a deer 40 meters ahead on the road. It takes 0.5 seconds before the driver hits the brakes, slowing down at a rate of 6 meters per second squared. How far did the car travel before stopping, and will the car hit the deer, assuming the deer doesn't move? It says it doesn't move, but it means the deer. Okay, so this is an example of reaction time. So the car is traveling 20 meters per second, and the driver sees the deer, and it's like, oh, look, there's a beautiful deer there. Oh, isn't it pretty? And then after a half a second, it's like, oh, shoot, it's not moving. I should step on the brakes. But during all that, the car is moving. And so the two parts are the reaction time, where the car is still traveling at a constant velocity of 20 meters per second, and then the slowing down part. Okay, so just two sections. In the reaction time, it's a VAV. A VAV is 20 meters per second, and this time lasts for a half a second. And then the driver hits the brakes. So in the slowing down part, the VI is the VAV, slowing down at a rate of 6 meters per second squared. So A is negative 6 meters per second squared. And it says before stopping, VF is 0. And the question is, how far will the car travel before stopping? Well, it travels some distance before hitting the brakes, and it travels some distance after it hits the brakes while it's stopping, and you need to find both. So first, under reaction time, VAV equals delta D over delta T. So delta D is equal to VAV times delta T. So delta D is equal to 20 meters per second times a half a second. Should give you about 10 meters. Okay, so that's how far the car travels before stepping on the brakes. Now over here we have to find out how far it travels while it's trying to stop. We don't have a time here, so you want to use VF squared is equal to VI squared plus 2A delta D. And you want to rearrange for the delta D. So VF squared minus VI squared, and then divide by the 2A. And the VF goes to 0. So delta D is equal to subtract, brackets, 20 meters per second squared over 2 times negative 6 meters per second squared. So on the top is negative 400. On the bottom is negative 12. Delta D2 is going to end up equaling 33.3 repeating meters. How far does the car travel before stopping? It's the two of them added together. The T total will be equal to D total, D1 plus D2. So it will be equal to 43.3 meters. So answer to the last part, will it hit the deer? Yes, if the deer doesn't move. And so you do have to write a statement with this one, because just saying the delta D is not enough. Okay? Example 3. This one is an object falling and one moving horizontally. Okay, so for example, a kitten is falling from the branch of a tree 4 meters above the ground. So here's the kitten. And yeah, it kind of looks like a giraffe or something. 4 meters above the ground. So for the kitten, the delta D is 4 meters down. It's falling, so the VI is 0. Guess we should have finished reading the question, huh? Above the ground, you are standing 6 meters away. How quickly must you accelerate in order to catch the kitten just before striking the ground? So you're going to dive for this kitten. So you're going to catch it stretched out here with your hands up. Okay? So the kitten's going to fall the whole 4 meters. So there's the kitten, and there's you for the givens. So for the kitten, that's a 4 meters down. VI is 0, and A, because it's falling, is 9.81 meters per second squared. Also down. Excuse me, I have a tickle. You're standing which means your VI is 0. And you're standing 6 meters away, which means your delta D is 6 meters. How quickly must you accelerate? We're looking for the A. And what is it that joins these two? How long? We don't know how long it takes the kitten to fall. But however long it takes the kitten to fall, that's how long you have to get over there. So you're going to start with the kitten, because if you look at this set of unknowns, or set of givens, there's only one unknown. It's the delta t, so you can find it. Then you can use it over here, and then you can find the a, because you'll only have one unknown. So a delta d of vi, and a, and a delta t, you want delta d is equal to vi delta t. 1/2 a delta t squared. The vi term goes to 0. Multiply both sides by 2 to get rid of the 1/2. Divide by a. So you'll have t squared is equal to 2 delta d over a. So 2 times 4 meters over 9.81 meters per second squared. Remember, that's going to be t squared, so you need to take the square root. And when you do, you get 0.90305 seconds. That you're going to use up here. Okay, so now you want A, you have a VI, a delta D, and a delta T, same equation. Delta D is equal to VI delta T plus 1/2 A delta T squared, only this time you're using it for U. VI is still 0, and this time you're solving for A, so multiply both sides by 2, and divide by T squared. So A will equal 2 delta D over T squared. So 2 times, you had 6 meters to go, and the T was 0.90305 seconds, and you don't forget to square it. And when you do, you get 14.715 meters per second squared. Okay, so it's just another example of a two-step question where they're connected somehow. So here they're connected with the times. We're going to do one more. You're on a bike and stopped at the side of a road, so you're one of the people. When a friend on a bike goes by 12 meters per second, so your friend is the second thing involved. You immediately started to catch up, accelerating 0.8 meters per second squared. How far have you traveled? Okay, so for you, you're on the side of the road, your VI is 0. But then you accelerate to catch up, and you accelerate to catch up at 0.8 meters per second squared. And it wants to know how far have you traveled, delta D, and how long does it take, delta T. For your friend, they don't know they're trying to catch you. You're trying to catch them. They're just minding their own business, listening to their tunes, going 12 meters per second. We don't know how long they pedal before you catch them. We don't know how far they go before you catch them. But what we do know is the D's are the same and the T's are the same. Sorry, I should have written them in the same order. Okay, we can get an expression for delta D here. It'll be delta D for U is equal to VI delta T 1/2 A delta T squared. And the VI term goes to 0. So your delta D is 1/2 A delta T squared, but I can't find it because I have two unknowns, the time and the delta D. Over here, I can get a delta D for your friend. It's just going to be VAV times delta T from the VAV equals delta D over delta T equation. Okay, so, but I can't find it because I don't know either of them. But what I do know is that the delta D's are equal. And so I can set them equal and solve. So I can do 1/2 A delta T squared equals VAV delta T. All right, now I only have one unknown. I can divide both sides by delta T to get rid of it over here and to get rid of the squared. And so now I have 1/2 A delta T equals VAV. Multiply both sides by 2, divide by A. So 2 VAV over A. 2 times 12, 24. Oops, divided by 0.8 meters per second squared. There's no squared there. And when you do, you get a delta T of 30 seconds. And then to find out how far, fill it back in.